Hi guys, we are preparing for NSET, and in this topic we would discuss Venn diagrams. So we would discuss what sets are, how does intersection work, how does union of sets work, and what is the inclusion exclusion principle. So this is going to be super important for solving questions. We would also take a look at a few examples. Okay, so sets are groups of data points, and the only necessary thing is there are no duplicates. Okay, so what could be an example of sets? So for example, let us say I am given a set of people, set of students learning physics. Okay, B is set of students learning chemistry. All right, so let us say a is the size of A is 20 and the size of B is 30. Now there's another thing that is given to us, that is how many people learn both the subjects together. So that is called an intersection of the sets and represented by A intersection B, which would represent set of students learning both physics and chemistry. So there could be students who are learning only physics, there could be students who are learning only chemistry, but there is also a possibility that there is a certain set of students who is learning both physics and chemistry. That is called an intersection. So let us assume that set is of size 10. So this data here tells me that this A represents people who learn physics. So there are 20 of such guys, or let me change the data to slightly smaller values. So let us say these are 8 people, let us say these are 5 people, and let us say 3 people learn both. Okay, so I am representing 8 points here, 5, 6, 7, 8. So this set represents, there are 8 data points, this set represents that 8 people learn physics. Now there is another set, B, and which has size of 5. So 1, 2, 3, 4, 5. So this represents that 5 students learn chemistry. Now we are given that there are 3 people who learn both physics and chemistry. So how do we represent that? So to represent that, instead of making them separately, we would make them together. So this is A, and let me put 8 dots here, 1, 2, 3, 4, 5, 6, 7 and 8. All right, now see this intersection, B. If you take a look at only B, you would see that you have 5 data points here, representing that 5 people are in set B or 5 people learn chemistry. Okay, but if you look at set A, I can also say that 1, 2, 3, 4, 5, 6, 7, 8. 8 people learn physics. Now which part represents A intersection P? This part here, these 3, this and this. These 3 represents the intersection. These are people who are in A as well they are in B. So they are both in A and B. So this represents A intersection B, means the people who learn both physics and chemistry. Okay, so by taking a look at this diagram here, which is called a Venn diagram, I can see this is A, or people who learn physics, and there are 8 constituents, 1, 2, 3, 4, 5, 6, 7, 8. This part here is set B, or people who learn chemistry, that is 1, 2, 3, 4, 5 constituents here. And if I have to take a look at the part where people learn both physics and chemistry at the same time, so there are only 3 such people, which is this one, and this one. This part is a part of set A as well as a part of set B. Okay, so what is now A union B? A union B means people in set A as well as in set B, but there should be no duplicates, which means A set B here would be of size how much? So I would say 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So A intersection B would be of size 10. Let me again show you that. And for that matter, I would name the elements also. So A1, so I would call them A, B, C, D. So A, B, C, D, E, F, G, H. So these 8 people are in set A learning physics. So A, B, C, D, E, F, G, H learn physics. Now in chemistry, There are how many people? In chemistry, there are 5 people. So, and we also know that 3 people learn both physics and chemistry. So I would draw it slightly cleverly. So how I am drawing it is, see, this is how I intend to draw it. So what does that tell me about B, D and F? I know that B, D, and F are learning both physics and chemistry. But there are 5 people learning chemistry, so we need 2 such people who do not learn chemistry. So let me say those are I and J. Now A set is actually A, B, C, D, E, F, G, H. 8 people in set A. And B has I, J, B, D, F, B, D, F. A intersection B is people who are in both the sets. So if you see BDF is here as well as here. And you can also see that from the Venn diagram. BDF is a part of both the sets. So that is what is called intersection. People learning both physics and chemistry. So that is BDF. What would a union be? What would a union be? So union signifies all the people, part of A as well as part of B, but no duplicates. For example, I would keep them, but I would not repeat BDF twice. So I would keep them once only. So I would write A, B, C, D, E, F, G, H. So this is A. From B, I would only pick I and J, but not BDF. Why? Because that would be a repetition. So that is what a union is. So this is what a union is. So union, while picking union of A and B, we would not pick the duplicates twice. We would keep them only once. So that is what a union is. Alright. There is also terms like A minus B. People in A who are not a part of B. People in A who are not a part of B. So that would only mean from the A we would have to reduce the intersection. So basically A minus. So this A minus B set is actually, it means, or I would say only A would mean A minus subtract the intersection. People who are only a part of A, not of B. So you would have to subtract the intersection part. So I would call intersection is BDF and the entire A is A, B, C, D, E, F, G, H. So I will have A but not B, C but not D, E but not F, G and H. Similarly, only B would be represented by B minus A intersection B. So B has I, J, B, D, F from here, and you can also see it from here. I, J, B, D, F. But we do not want the intersection. Only B means only I and J. So B minus intersection was BDF here, and you can also see the intersection BDF in this diagram. So we would subtract the intersection. This part here was the intersection. So we would get from IJ BDF, if I have to subtract BDF, I would get I and J. So you need to be familiar with these terms. This is A, this is B, then this is intersection, part which is common in both. Union is the entire A plus the entire B, but not the duplicates. Okay. Only A is A minus the intersection, only B is B minus the intersection. Alright. Now the most important thing, which is called the inclusion exclusion principle. So you have to understand that, and we would also do it for 3 sets. So this says that A union B is equal to A plus B minus A intersection B. And you have to think why so. So see, because union does not have duplicates. So if I have A, B, C, D, E, F, G and H. So A has, I would have to repeat that, A has A, B, C, D, E, F, G and H, 8 people. And B has 5 people, I, J, B, D, F. So let me say that this is I, J and B, D, F. So intersection we know, intersection is the common part, which is B, D, F. If I have to have all of them without the duplicates, so what I would do is I would pick the entire A and I would pick the entire B. But you have to see that this intersection part got picked twice. It got picked as a part of A, it got picked as a part of B. So I'll have to subtract it once. Again, see. So let me try to make union of A and B. So let me pick the entire A. So this is me picking the entire A. So I would pick A, B, C, D, E, F, G, H. Now let me pick the entire B. So when I picked the entire B, I got A, I, J, B, D, F. But do you see, I have picked BDF twice. So I would have to subtract BDF once. And what represents that? That is represented by the intersection. So I can say A union B is A, which is this, plus B, which is this, minus BDF, which is the intersection. Why? Again, if you have not understood it, take a look again. When you pick the entire A, and you add the entire B to it, you have to see that this part here, this part here, which is the intersection, got picked it twice as a part of A as well as a part of B. So you have to subtract it once. So that is why we get A union B, A plus B minus A intersection B. And how does it work for more sets? So let us say we had 3 sets. A, physics learning students, B, chemistry learning students, C, maths learning students. Okay, and let me try to draw it. This is A, this is B, and this is C. A is physics, B is maths, C is chemistry. So here you would see that there is an intersection of A and B. This part here is the intersection of A and B. This part here is the intersection of A and C. This part here, this entire, the one that I am tracing right now, is an intersection of B and C. So let me try to show it in different colors. Let me again do it. So let me choose, this is A, okay, and this is B, and let us say this is C. This is C. So I have A, B and C now. A, B and C now, and I would try to fill the 2 parts. Try to fill the different intersection parts. So let us focus on A intersection B. A intersection B actually is, I think, this part. This is A intersection B. Okay. And what part is A intersection C? This thing here is A intersection C. Okay. And what part is B intersection C? This thing here is B intersection C. Now there is a unique place here, which is the part that, unique place here, this part. This is intersection of all 3 people learning physics, chemistry and maths. So this part here, this central part is A intersection B intersection C. Now when you want to have a union of A union B union C, if you want to know all the people, all the students, so you would add A plus B plus C. But you have to realize when you add A and B, this part get added twice. A intersection B get added twice. This part here, that get added twice. So I would have to subtract that, A intersection B. When we added A, B and C, this part also, that is intersection of A and C, also get added twice. So I will have to subtract that. This part also get added twice. So I will have to subtract that also. Now you have to very carefully think that when we subtracted these 3, this part got excluded completely. So I will have to add that again. So let me show that with a diagram as well as an example. Let us say A has 5 people, A, B, C, D, E. And B has, let us say that also has 5 people, but 2 of them are in set A, D, E, G, H, I. And let us say C also has a few people, or let me make a little larger set, A, B, C, D, E, F. Okay. Now, second set has D, E, F from the first set. So let's say these learn physics. So small A, B, C, D, E, F learn physics. Set B, that is chemistry, is D, E, F learn chemistry as well as G, H, I learn chemistry. Okay. Now in C, I would pick E and F, and A, and let us say G and I, J, K, L. So let us try to draw this now in diagrams. Okay, so this is A. So I will have to write A, B, C, D, E, F here. So I would write A, B, C, D, E, F. Okay, now chemistry, set chemistry, which is set B. So I picked, I would put the elements later on, and let me also have C here. Now I would try to put the elements. So let me first put the elements which are only part of A. I think the only people part of A is B and C here, which is not part of any other set. So B and C is picked. Okay. Now I would pick D, E, F. D, E, F here. D, E, F is a part of B as well as A. So I would have to put it strategically. So D, E, F. So if you see, for now, if I would focus on A, this is A, and I have B, C, D, E, F taken. B, C, D, E, F taken. A is not taken yet, so small a is not taken yet, so I would also put that somewhere. Let me put it here. Okay. Now, if you see, my set A is complete. Everyone is picked up. A, B, C, D, E, F is picked up. So this is small a, B, C, D, E, F, all picked up. Now let me try to create set B. So it has GHI, DEF. Okay, so let me put H and I. DEF are here already as a part of B, and G is also there. So G I would put, because it is an intersection with C. So G I would put here. Now let us see if C is done. If you focus at C now, A, E, F and G are already here. K and L I would have to put separately. Okay, now let's see. According to this, we already have the A set, B set and C set. Help me identify A intersection B, which is this part. And I think the people in this part are DEF. So it is clear from the diagram also, and it is clear from up also. A set has A, B, C, D, E, F. B set has D, E, F, G, H, I. So DEF is the common part, so I would put that there. Now B intersection C. This set is B and the lower set is C. So I think the common element in B and C are in this area here, which is EFG. So from the diagram I have picked it, and I can check it from the above information also. B is DEFGHI and C is EFAJKL. So KL is not above, and I think A is also not in B, but DEF, I think E is part of both and F is part of both and G is part of both. So EFG is correct data. Now A intersection C, let us pick it from here first. Is E a part of both? Yes. So that has E. Is F a part of both? Yes. So F would be there. Is A a part of both? Yes. So A would be there. Is G a part of both A and C? No, G is not there. K is not there. L is not there. So EFA. And let us confirm from that from the diagram. Yes, I see. This is set C and the above one is set A, and I see A, E and F in the common part. Now let us focus on the A intersection B intersection C, which is everyone has that. From the diagram I can see this area here has E and F. So it should contain E and F. Let us focus here also. So is A a part of all three? No, A is not a part of all three, so that would not be there. Is B a part of all three? B is not a part of all three. Is C a part of all three? No. Is D a part of all three? No. Is E a part of all three? E is here, and E is here also. So yes, E would go into A intersection B intersection C. Is F a part of everyone? Yes, F is a part of everyone. So my A intersection B intersection C would have E and F. Now how about the union? So I would pick the entire A first. So I say the formula is pick entire A, B, C, subtract the common parts, and then add the super common part. Let us see how that works. So A is actually A, B, C, D, E, F. Alright. So I have A, B, C, D, E, F. Now B, have the B. B is D, E, F, G, H, I. D, E, F, G, H, I. So we already see when we added A and B, D, E, F is added twice. So we have to subtract that. So instead of adding C now, I would focus on A intersection B. So I would subtract D, E, F. A intersection B. So we know that we had D, E, F as the intersection. We subtracted that. So 1. So D, E, F is only 1 times now. It is not duplicated. Now let me try to add C. If I would add C, I would get E, F, A, J, A, G, K, L. E, F, A, G, K, L. So C is also taken. Now B intersection C has to be considered and subtracted so that the duplicates of B and C gets removed. Duplicates of B and C were E, F, J. So common part of B and C was E, F, J. E, F, G. So why removing that? Because E, F, G is coming already here. It is a part here also. And E, F, G I can see one set again. So I would have to remove that. E, F, G has to go. So removing B intersection C, remove the duplicates. Now C intersection A for the duplicates between A and C. C intersection A was EFA. So I am subtracting that EFA so that I do not have, for example, A twice. So A was twice. So I would keep one A, the other A would go. E and F would also go. Now what has happened is this common part had E and F. That is all subtracted all together. This common part is not coming at all. So we would have to add A intersection B intersection C again. When I would add this again, I would reintroduce E and F because they got removed. So eventually this is your union. So if you would see, we have actually everyone once. So see, I have A, B, C, D. I have E, F, G, H, I. I don't think we missed J. J was not a part of the data. K and L. So everyone is there. So this is called the inclusion exclusion principle, which means if you have set A, B, and C, A, B, and C, A, B, and C, and you want all the people, you want to know the union, no duplicates. So you will have to add A, B, C, which is you add A, then you add the entire B, then you add the entire C. But this would give rise to duplicates, so you will have to subtract A intersection B. You will have to subtract that, A intersection B, because that is a part of A and B both. So you will have to subtract that. You would have to subtract A intersection C, because that is a part of A and C both. You would have to subtract B intersection C also, because that is a part of both B and C. So when you removed this part, you removed this part, and you removed this part. So this part got removed altogether. You'll have to add that back. So you'll have to add A intersection B intersection C. Now when you have this thing, you would have elements of A, elements of B, elements of C, as well as the common part. Alright, so let us meet in the following examples and try to understand it more. Alright guys, now let us practice a few questions on the Venn diagrams or the set theory. So here what is given to us? Bus, train and metro. Bus, train and metro. Okay. So 60 people use bus. So let me say bus set has 60 people. Train set has 50 people. And metro set has 40 people, which is given to us. Metro has 40 people. Okay. 20 use both bus and train. So I would say bus intersection train. Instead of writing bus, train and metro, I would write B, T and M. Bus, train and metro. So how many people use both bus and train? 20. So bus intersection train is 20. 10 use both train and metro. So train intersection metro is 10. 30 use both bus and metro. So that data is 30. And 5 use all three modes. So that is intersection of everything. Intersection of everything. 5. So how many people are there? Which means the union of bus, train and metro. So you would have to add BTM by the inclusion exclusion principle that we already know from the topic video. So I would subtract these and I would then add back B intersection T intersection M. So 60, 50, 40, 60, 50, 40 minus 20 minus 10 minus 30 plus 5. So whatever that value is, I think that value is 95. So there are a total of 95 commuters. Alright, let's meet in the next question.